Okay, this problem is for a specific problem in your textbook, page 321, number 9. It's using quadratic applications for max-min type problems. So question A, or so the original the question is, tells us that 40 meters of fencing are used to enclose a rectangular pen. I don't know, maybe it's a farmer or something. The area, A square meters, enclosed, okay, so we actually have a formula for what the area of this rectangular pen is. So I think that's our rectangular pen. The length of the pen is x meters, so the length of the pen is x, and the area is 20x minus x squared. Okay, and it's a rectangle. So the question is, I don't know why I have that there. The question is, what is the maximum area that can be enclosed? Okay, well, first of all, this is a quadratic, so we know that if we were to graph it, we're going to get something that looks like this, and I know that because my x squared has a negative coefficient, so I know it opens down. So what's the maximum area that can be enclosed? So what this means is, what area, in other words, what's the area that's going to give me, or what's the maximum area going to be given a specific dimension for x, right? Because I can have all kinds of rectangles, right? I can have really tall skinny ones, I can have squarish ones, or I can have really long ones like that. All kinds of different rectangles, but there's one dimension or one specific type that's going to give me a maximum area, and I need to find out what that is. So I'm given A equals, I'm going to rearrange this. Well, maybe I won't. Maybe I will. Sure. Let's do that. Let's rearrange this slightly so that rather than 20x minus x squared, I'm going to start with negative x squared plus 20x. And it's asking me to find the vertex. Essentially, that's where we find maxes and mins with parabolas, is where is the vertex. So how do I do that? Well, I would have to solve for I would either have to solve for the x-intercepts and then average them. Maybe I'll do it that way. Solve for the x-intercepts and then average them. So I'm going to factor out the common factor of negative. So first, I guess, I will solve for the x-intercepts. And in doing so, I will have to set a equal to 0. Therefore, 0 is equal to, okay, now I will factor my common factor of x, negative x, and I'm left with x plus 20. Therefore, x is either equal to, well, negative x. Half of me is trying to skip steps, the other half is trying to do all of it. So, therefore, either negative x is equal to 0 or x, I'm having writing issues today, or x plus 20 is equal to 0. I've made another error. Silly me. Oh no. X times, this should be x minus 20, not plus 20, which means this should be minus 20, not plus 20. So therefore, x is equal to 0 or x is equal to 20. Well, if x is equal to 20, then this is going to be my answer, because x equals, well, having a no length rectangle doesn't make any sense. So, therefore, my two x-intercepts are 0 and 20. Therefore, the x vertex, or the x-intercept, or the x portion of the vertex, is going to be the average of them, which would be 0 plus 20 over 2, which equals 10. Okay, now the thing that I'm actually looking for in terms of the question is the y part of the vertex, which would be substituting 10 back into the equation. So negative 10 squared plus 20x, that's equal to negative 100. That's x times, that's an x, plus 200, which equals 100, and that is our maximum area. Okay, that's our maximum area, 100 meters. Okay, and we did that by finding the coordinates of the vertex. So 10 max area is 100, so our parabola looks something like that. And that's our vertex. Okay, that's if you wanted to solve it in standard form. I'm going to erase this for a second. If I wanted to solve this using vertex form, right, because it's easy to find the vertex in vertex form, I would have to complete the square of my original equation. And to do that, I'm going to still write it in this rearranged form. And here I go. X squared minus 20x. Good. Negative x squared minus 20x plus half of this squared minus the same thing equals negative. These three things factor into x minus 10 squared, and I still have to have minus 100 tacked on the end here. And then I'm going to redistribute the negative just to get it into vertex form completely. So negative 1 times negative 100 gives me positive 100. Vertex. There we go. So vertex is 10, right? Positive 10 and positive 100. Positive 100 and positive 10. Therefore, my max area is 100. You can decide which one's more efficient for you. Now, question B says, what are the dimensions of the pen with maximum area? Well, we already know that max area equals 100 square meters, and we know that that occurs when x is equal to 10. Well, I have 40 meters of fencing, and I know that the length is supposed to be 10, which means that this is supposed to be 10. And I know that 10 plus 10 plus, well, we'll call this the width rather than the length. Let's call this the width, plus 2w is equal to my total of 40. So 20 plus 2w is equal to 40. 2w, trying to isolate for w, is equal to 20, so w is 10. Lo and behold, the length and the width are all 10. In other words, it's a square. And then your final statement or whatever. And lastly, what dimensions produce a pen with an area greater than 90 square meters? Well, let's find out what dimensions actually give us an area of 90 square meters. So I'm going to solve this quadratic when area is equal to 90. All right, here I go. 0 is equal to, and again I'm going to rearrange this so that I'm leading with my negative x squared plus 20x minus 90. These kinds of questions, yeah, I could try and factor or whatever. I'm just going to jump to the quadratic formula. Negative 20 plus or minus the square root of 20 squared minus 4 times a, which is negative 1, and c, which is negative 90. All over 2a is negative 1. So negative 20 plus or minus, handy dandy calculator, and I know that 20 squared is 400, and then I have negative, 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 so it's 3 negatives. 400 minus 4 times 1 times 90. Well, 4 times 90 is 360. Whoops, not 630. 360, and I get square root of 40. So, plus or minus the square root of 40 all over negative 2. So, I should get, if I were to do this in my calculator, I should get my two answers. I don't know why I'm starting with the second answer. First one, negative 20 plus the square root of 40 is that, and then divided by negative 2, and I get about 6.8, or 6.8. Or the other answer is negative 20 minus the square root of 40. That all divided by negative 2 and 13.2. Okay, so we got two answers that are both valid, right? Because I can have length be a positive number, and these happen to both be positive numbers. So let's go back to the question and see which one, or how we deal with two answers. What dimensions produce a pen with an area greater than 90? Well, let's just do a little quick sketch here. I know that my x-intercepts are 0 and 20, and I know that my area maxes out at 100. So something like that, maxing out 100. Meaning that an area greater than 90, well, 90 is about here. Meaning that I'll have an area of 90 for some x value, or length value, and I'll also have an area of 90 for a second length. In other words, there's two rectangles that give me the same area of 90. So if a length of 6.8, okay, if a length of 6.8 gives me an area of 90, and a length of 13.2 gives me an area of 90, in order to have an area greater than 90, I would have to be between these two values. I would have to have a length that is bigger than 6.8 meters. Now remember, our optimum, right, max area occurred when it was 10. So I need to be above 6.8, or 10 if I want to have a max. So a length bigger than 6.8 and less than 13.2. So as long as I have a rectangle that has a length between these two values, then I'll have a total area that's bigger than 90. It might not be 100 unless I'm smack dab on 10, but at least it'll be bigger than 90. So in terms of the dimensions, okay, I know that my length has to be between these two values. So 6.8, 6.8, W, 6.8 times 2. Well, I'm not very good at math in my head, so 6.8 times 2, 13.6. Ooh, interesting. 13.6 plus 2W is my 40, so 2W is 40 minus 13.6, and then divide that by 2, so 26.4, or the width has to be 13.2. Interesting. Notice how the width and the length are actually the same rectangle. So for all intents and purposes, I have one rectangle where this is 6.8 and 13.2, and the other one where it's the exact same rectangle, it's just tipped on it, it's sideways. There you go.